All right. Here we go. This is like the third time we've seen Alicia, but again, I told you I wasn't going to cover these a lot because you have an entire study packet and we did it on video too, I believe, where you can go back and look at motion graphs. All right, so I'm not going to spend a lot of time on these. The graph shows how far she is from at home. What is she doing from 3 to 4? 3 to 4. Addie, what am I doing here? Am I going up a hill? No, that's the misconception, right? Is it acceleration? No, because that would be a speed time. What am I doing when I'm doing that? Constant speed, but if I look down here, that's not a choice. Is she getting close to home, not moving, riding up a hill, which you said it's not this, or is she moving farther away from home? Moving farther away from home. So I love the fact that you knew that was constant speed, moving farther away from home. So that tells me you've been studying your motion graphs, which is what we all need to do. Pretty easy. We're not going to spend a lot of time on that because you have an entire video on that. So I'm not going to do this one because we've already done this one in a video. Whoops, I do need to go back and do number 12 though. Here we go, number 12. This was something that really kind of blew my mind. That's why we actually did this experiment in class. Because some people, I know that, but I'm doing it again. Some people thought that if I rolled a ball down a ramp against the wall, the ball would just stop. We learned, because of Newton's third law, for every action there's an equal and opposite reaction. If the ball does not stop, what does it do, Kenny? It bounced off the wall and traveled in a different direction. It does not stop moving. I understand people thinking it would stop, and that's why we did the experiment. It certainly doesn't move faster when it hits the wall, and it doesn't travel at the same speed because the wall takes some of that force into it. We learned all about that, especially when we did the experiment. I think it was pretty good. 13. A soccer player is outside kicking a ball across the field. We've all done this with like a soccer ball or a kickball outside at recess at some point. What factor has the most effect on the distance the ball travels? So now Keegan, we're back to that thing. Where did Keegan move to? She's over here now. Where there's probably more than one good answer, right? Probably. And I remember this when there's two good answers, but one of them has the most effect. Now, if we went outside and I gave you an orange soccer ball, a green soccer ball, and a blue soccer ball, does that change how far you can kick it? The color has no bearing. I know that you might think that if you're at home and you've got your special soccer ball with your favorite team logo on it, you can kick it further. You can't, okay? You just can't. How about the force of the kick? Does that have an effect on how far the ball goes? Yes. I'm thinking, boy, oh boy, there better be a really good answer, way better than that, because that's probably the one I'm going with. What about the length of the field? No. The field could be short, the field could be long, depending on how hard you kick the ball, though, is what really matters. Now, we talked about this. What about the temperature of the air? It does affect how far the ball goes, because as the temperatures get hot, the soccer ball expands. As it gets cold, the soccer ball is going to contract. The air in the soccer ball is going to contract, and that will affect how far you can kick it. But it didn't say which of these has an effect. It said which of these would have the most effect. Now, this has an effect, but what do you think has a greater effect? Air temperature or how hard you kick the ball? It's how hard you kick the ball, so you should be able to work your way through that one. I think that one's pretty easy. Gannon, would you agree with that? All right, Daniel, I'm not even going to move down. I have no idea what the question is, but I see some question that's got 4 trucks, and the trucks get bigger and bigger. They go from 10 to 20 to 30 to 40 grams. And I know without even reading it, it's going to ask me something about which of these is the easiest to push or the hardest to push, or which one would go the furthest if I pushed it with the same, right? It's that same question that's telling you that how big something is determines how much force you need to move it, which is Newton's second law. You know that. But we scroll down, and Daniel says, if these trucks are pushed with the same force, which one would roll the farthest? Truck 1. Why truck 1?
Because it has less mass.
It has the least amount of mass, and therefore, with the same amount of force on all 4 trucks, would go the farthest. It's that simple. Don't let all the numbers and the size of the trucks and stuff, that's the easiest question you can get, because you all know the bigger something is, the more force it takes to move it. You've been crushing that. 15. Students investigate how the force of wind affects the movement of equal-sized balls that have different masses. And we looked at a ping pong ball, we looked at a golf ball, and said they're about the same size, but the golf ball has way more mass in it. You all agree with that? So if we took a golf ball and we took a ping pong ball and we cut on a little tiny fan and started blowing it, the ping pong ball would move. The golf ball might move a little bit, but probably not very far, right? I'm talking like that little bitty fan that you can plug into the bottom of your iPhone, that little thing, you know, and it's barely blowing. It would move a ping pong ball because the ping pong ball has little to no mass. The golf ball, probably not. And if there was a bowling ball there, it's not moving it at all, right?
It would break your phone.
So you look at these and you say, okay, ball number 1 has 30 grams, ball 2 has 20, ball 3 has 10, and ball 4 has 40. And if we know what we know, ball 3 should have moved the furthest. Oh, wow, it did because it has the least mass. The next one should be ball number 2, and it is. We look down here, ball 2 has 20. Then the next one should be ball 1, yep, because it has 30. And then the last one will be ball 4 because it has 40. And we're correct about that. Based on the results, what should the students conclude? A, the balls move easily when their mass is higher. No, that's the opposite. It takes more force to move them. Balls move farther when the wind speed is lower. That doesn't make sense because that's saying it's applying less force. So that can't be the answer. So we're really narrowing this one down. Balls move farther when their mass is lower.
Yes.
D would have to say something about, I'll give you $1 billion if you answer this question before I would answer the next question, because it's not going to get any better than that. Balls move quickly when their size is larger. No. So the answer, boys and girls, very easily is C.